Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer use model.
Bioactivation of testosterone and saturation points. What happens after transport? Now that we understand how hormones are transported through the blood, the next question is simple. What happens when testosterone actually reaches the cell? This is where bioactivation occurs. Testosterone doesn't stay testosterone forever. Once inside a cell, it can be transformed into different metabolites, each with very different effects. This transformation process is called biotransformation, and understanding it is critical for predicting both results and side effects. The three biotransformation pathways. Testosterone can be biotransformed in three main directions. First, into a more potent androgen. Second, into a weaker or inactive androgen. Third, into estrogen. Which direction dominates depends on enzymes, tissue type, and individual genetics. This is why two people can take the same dose and have completely different outcomes. Testosterone to DHT via 5-alpha reduction. The first pathway is conversion to dihydrotestosterone, aka DHT. This happens via the enzyme 5-alpha reductase. Tissues with high 5-alpha reductase include the liver, kidneys, prostate, skin, scalp, brain, and pancreas. DHT is a much stronger androgen than testosterone. It binds more tightly to the androgen receptor. This explains androgenic side effects. More 5-alpha reductase in skin, higher acne risk, more in the scalp, higher hair loss risk. Everyone expresses this enzyme differently. That's genetic individuality in action. Why DHT is a poor muscle builder. Here's something most people get wrong. DHT is actually a very poor muscle builder. Why? Because skeletal muscle contains high amounts of the enzyme 3-alpha dehydrogenase. This enzyme converts DHT into a weak, inactive androgen. So even though DHT is powerful elsewhere in the body, it does very little for muscle protein synthesis. This is why testosterone, not DHT, is the primary driver of muscle growth. DHT derivatives explained correctly. This leads to a major misunderstanding. DHT derivatives are not just DHT. They've been chemically modified so they cannot be deactivated by 3-alpha dehydrogenase. They also cannot convert to estrogen and cannot be further reduced into stronger androgens. This makes many DHT derivatives highly anabolic but low androgenic. In many ways, they're close to an ideal anabolic compound, especially for women. Why DHT derivatives were created? Historically, testosterone was used to treat advanced breast cancer. It worked but caused problems. It converted to estrogen, it converted to DHT, and that caused unwanted side effects. So pharmaceutical development aimed to create compounds that didn't aromatize and didn't convert to DHT. That's why compounds like Primobolan and Masteron were developed. They are not DHT, they are modified anabolic steroids designed for lower androgenicity. Aromatization, testosterone to estrogen. The third pathway is aromatization. The aromatase enzyme converts testosterone into estradiol. Not all anabolic steroids aromatize, many don't, especially DHT derivatives, but testosterone does. And this conversion plays a major role in mood, libido, water balance, and health. We'll later break down which compounds aromatize and which do not. Where bioactivation occurs. Most bioactivation occurs in the liver and kidneys. These organs take the greatest metabolic load. But local conversion also happens in skeletal muscle, brain, and other tissues. This is why liver and kidney health are non-negotiable in PED use. Enzyme saturation, explained simply. A key concept is enzyme saturation. Enzymes are limited. Once all aromatase or 5-alpha reductase enzymes are occupied, conversion cannot increase further. Think of it like workers and desks. Once every desk is filled, no more work can be done. This is why estrogen and DHT production eventually plateau as testosterone doses rise. Saturation points in practice. In practice, high testosterone doses increase the ratio of testosterone to estrogen and testosterone to DHT. Estrogen still rises, but at a slower rate. For many individuals, aromatase becomes highly saturated, around 400 to 600 milligrams of testosterone per week. This varies person to person, but the trend is consistent in literature. This explains why some people tolerate high doses well and others experience estrogen issues at low doses. Age, body fat, and estrogen. Older men typically convert more testosterone to estrogen. Why? Higher body fat, higher SHBG, lower metabolic clearance. The same dose produces different results depending on age and physiology. This is why dosing must be individualized, not copied. Receptor sensitivity matters more than numbers. Two people can have identical estradiol levels. One gets gyno and water retention. The other feels great. Why? Receptor sensitivity and gene transcription. Labs tell part of the story, but response tells the rest. How this shapes stack design. This is where coaching decisions are made. If someone converts heavily to estrogen, you may reduce testosterone and add a non-aromatizing compound. If someone struggles with DHT side effects, you may adjust compound selection. Stack design is not theory, it's response-driven. Testosterone as the stack foundation. Testosterone remains the foundation of most stacks. We titrate it upward until we find the point of maximal benefit with minimal side effects. That sweet spot is different for everyone. The goal is not more, the goal is optimal. Key takeaway. Bioactivation explains everything. Why side effects happen, why doses plateau, why individuals respond differently. Once you understand enzyme pathways and saturation, PED coaching stops being guesswork and starts being precision.
Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer use model.